All right, number 7, we have what we call like a composition of functions with trig functions. So we have sine of inverse sine of negative 0.2. All right, so these really aren't bad. There's just some terms that you need to be familiar with. So going back to the text, I've already flipped a couple pages. So this is 528, composition of trig functions. What it's showing you is that if you see this notation, which really these are inverses of each other that will cancel out, but when you have this function, you have to focus on the inside, whatever's there. The x has to be in the domain of sine x. So whatever the domain is, if this x is in the domain, then you just get the same thing because they pretty much cancel each other out. So as long as that's in the domain. Same thing for cosine, they will cancel each other out and you just be ended up with x if it's in the domain of the cosine, the inside function, and the same thing for tangent, has to be in the domain. It says something about special cases. So when you flip the order, now we have to focus on the range. Okay, so whatever the range of that function is. So when they put the inverse on the outside, now you're looking at the range, and if this value is in the range, then that will be the same value there. Okay, so what does that mean? What does that mean? What does that mean? We're going to start with sine inverse. So we're looking at this case here, sine inverse. X is in the domain. So we have to be between, if I go back a few pages, domain was between negative power 2 and power 2. Page 525. For inverse sine, negative power 2 and power 2. So this number, negative 0.2, is actually between those two numbers. So it just says, okay, this will cancel this out, and this will be our answer. So we don't actually have to do any work. You just got to understand that property. So just negative 0.2, that 0 is not necessary. As long as that number is in the domain of the inner function, then it just cancels out and gives you that answer. All right. So number 8, cosine inverse of, got a bracket here, cosine of negative pi over 2. All right, so look at this one. That gave me negative pi over 2. All right. That is not in the domain of cosine. Let's see, inverse. We need to be between 0 and pi. That's where our restriction is. Because they switched it around on us. So, anyway, a better way of thinking about this, just another way of doing it, is we can just actually find cosine of negative pi over 2. So, let me just show you how to do it from the unit circle. That might be even better. I want to be able to just explain it and you guys get it pretty easy, but this will work as well. Okay, so power 2 is going like a fourth forward. Negative power 2 would be going here. So if you went backwards, negative power 2 would be this point. The x coordinate of this is 0. So what that tells me is that this is equal to 0. So now we're doing this. Inverse cosine of 0, because that's equal to 0. So inverse cosine of 0, now I'm looking for 0 in the order pairs. Remember our restriction. We have to be between 0 and pi. That was our restriction. between 0 and pi. So I'm looking for the x value to be 0 between 0 and pi. So between 0 and pi, this top half, I'm looking for the x value of 0. X value is 1. Here's x value 0. So it corresponds to pi half. So there's a couple things you can do to kind of understand this. They divide out. You still get that same value, but it's positive. So why did it change signs and that one didn't? Okay, so there's some other properties called even and odd. So I pulled up the Trig cheat sheet from the Mylab. If I can zoom in a little bit. So right here, the even and odd shows you that if you have a negative angle with sine, your ultimate answer will be negative. If you have a negative angle with cosine, your final answer will be positive. So it gives you the positive of it. So that's another thing that can help you explain why it changed signs. But it's coming from the code or composition of function formula. So just pi over 2, pi divided by 2, and that gives your answer here.